project, he happened to mention that if I wanted to do something, I could. That was the extent of what I was told. I researched the flamenco dancing, and I thought, well, that would be a good off-season project for the club to build a flamenco dancing robot. But I proposed it to the club members and it said, if you're interested in this, we'll do it, but you have to be committed to it. And to a person, they were all committed to it. We have a tremendous amount of freshmen that all worked on this project. And I'm not going to tell you about the robot. I'm going to let these fine young men tell you about the robot. I would like to mention this. This dress was designed and made by our own Doris Powers with help from her daughter. The head was taken offline, something that was posted offline, and we then down imported it and printed it out on the 3D printer. And it was just, of course, plain white. So I took it to Miss Nicole Barone, and she got Gary Mejia, who is in her 7th period art class, to paint the head, and he did a phenomenal job with that. And then the rest of it was a lot of work and a lot of mechanics, and I'm going to let these guys tell you about it. But this gentleman here is Mr. Eric Sloweski. He has been with the Robotics Club all 4 years, the first and only person to do that. He is going to Drexel as a mechanical engineer major. And many people around the school know him also as the guy who fixes their printer. And this gentleman here is Mark Masserotto. I remember. One of the brightest students I've ever had, and I'm not just saying that because he's planning on getting a PhD in physics. He was accepted to a summer program at the University of Pennsylvania where they're going to study particle physics. Right? So we're extremely excited about that. And then I'm just going to, and just so you know, that all the programming for the robot was done by them, and pretty much everything. I was there as an assistant, so I'll let them take over.
So, like Mr. Fiacco said, he came to us with this idea, I guess, a month and a half ago, around then, and we all wanted to do it. So, in the beginning, we threw around different ideas, different prototypes on how we could accomplish this. And so, to break it down, you see we basically have two different major components, the robot itself, and then this machinery underneath. These are the parts we actually use on our robots that we build for our competitions. That's run by a computer over there, and that's responsible for moving the robot around. And Eric's going to be controlling that with an Xbox controller. The robot itself runs off of a device called a microcontroller, which is where we load our program. We wrote it in a programming language called C, which is similar to Java that many of you may have. So the robot itself, we built all these different parts. We cut strut, plates, and we put it together over the past month. We have here servo motors, which are small motors that can run off of not very much power. And that's what's going to control the different joints and limb movements. So by coordinating them with our program, we're able to effectively demonstrate flamenco dance. We have a number of different leg movements, arm movements, and we have a speaker in the back. Finally, Mr. Fiacco mentioned the head. We have a motor that's going to move the head around, but you'll see all that when we actually get the dance going. So in building this, we were able to make use of the 3D printer in the back. We 3D printed this head and the feet down here. We actually 3D printed legs too, which Eric's holding. So Eric.
Okay. We decided to use servos because the whole point of a servo is that you can select a position of the servo and then it'll try to attain that position. So if you tell it to move like the arm like 360 or 180 degrees to the right, it moves to that position and then stays there. Unlike a regular motor, which you just tell it to spin in one direction by applying a voltage, and that would be much more harder to control it and make sure it doesn't like kill itself, which is not very fun. So we decided to use the servos in order to keep us more in check, and it's a lot easier to program that way and keep all the parts and all of the movements where we want them to be.
About that, one of the other groups was talking about using a coordinate system to measure the positions of the different parts. We didn't do something exactly like that, but all of the servos have angles, and so we have a big table of all of the angles needed for the different movements, and that's all in the program.
Like Mr. Fiacco said, all the stuff on the bottom has to be programmed in order for the Xbox controller to work with it. So you need to there's a lot of research that has to go in order to try and figure out what controls the Xbox controller uses in order to pass through to figure out and the computer to read those controls and then interpret them to turn motors and stuff to make the robot move around. Same thing with any controller that you use. But we decided to use the Xbox controller because it's a little bit more easier to use. It's it's more ergonomic for the hands, and I mean a lot of people use Xbox controllers, so it's more
Yeah, and in principle, we can have this run autonomously. It can move back and forth by itself, but we decide to use a controller. The dance itself will be autonomous. It's going to do that by itself. So.
Yeah. But because a lot of the kids that we know that come into the robotics program themselves, work, play with Xboxes and stuff like that, it kind of makes sense that get something they're used to in order to move the robot around and such.
All right, you want to demonstrate it?
Yeah, do you want? Throw it on.
Just one more couple of things I just want to mention. Just to illustrate the capabilities of the 3D printer, we ended up not using these legs only because, as anybody who's used a 3D printer knows, it's very finicky. Some days it wants to work, some days it doesn't. And so the legs were actually made, they were drawn out on paper, and we had mostly freshmen who downstairs in our shop on the milling machine and using drill bits and the lathes cut out all of these shapes so that the servo motor could fit in there. What this was is this was created in the computer using a software called 123 Design, and it was already pre-printed with the holes, with everything shaped out so that you could just stick the motor in there. So it kind of gives you an idea of the future of 3D printing and its capabilities. The only other thing I want to mention, I'll give a little iPad prop. We needed some music, and I was going to download some flamenco music from online, but I came across an app for the iPad called the Flamenco Machine, and you simply choose from a series of guitar, clapping, singing, drumming, and this gentleman here behind the camera is Andy Hearn. He's a freshman, he's in our robotics program. He's been with us all year, and he's actually the one that composed this. He took all the pieces of music and put it all together into... I also did it, but his sounded a lot better, so we're using it. Okay.
Is it right?
The wireless doesn't want to work.
I don't know.
Oh, I guess it's not going to be moving back and forth.
Okay, right.
I ain't ready. Okay, and one other thing we didn't mention, I'm going to pause this music for a second. You'll hear it's actually making a castanet sound. What they did is, from the microcontroller, you can send a signal to a speaker, so they just had to identify the frequencies of sound that would combine together sound like a castanet. And so they put a couple of hours in one afternoon putting it together and arrived, and everything worked great, and the computer that they had saved it to crashed. And we found that out about 4 o'clock yesterday afternoon. So in a half an hour, he he did it again, went through and put that sequence together so that that could be part of it. It's been going this whole time?
Yep.
Good, okay. We were having, I'm not one for commercials, I hate commercials, but I will say this, okay? I bought a pack of 20 Duracell alkaline batteries, and we went through all of them trying to get this thing programmed. So today, and it wouldn't get past one sequence of dance moves before it died. So I went out last night and bought lithium-ion ultimate batteries, and you can see the difference. So I'm extremely impressed with that. Does anyone have any questions for us about this?